In the 1930s, an American chemist named Russell Marker saw the future of sex in a field of Mexican yams. It had been known for some time that a group of biomolecules known as sex steroids could be used to develop the world's first oral contraceptive. But there were two problems. First, when a sex steroid like progesterone is ingested, it is rapidly metabolized by the liver, making it difficult to use in an oral contraceptive pill. Second, sex steroids were extremely expensive to obtain. In the 1930s, progesterone cost $80 a gram, a whopping $1,100 a gram in today's dollars, more expensive than gold. Before an oral contraceptive could be developed, the price tag would need to come down. That brings us to Russell Marker. While experimenting in the lab, he devised a way to produce sex steroids from yams. His process was so efficient it made sex steroids 40 times less expensive to obtain, paving the way for research in oral contraceptives. With the price of sex steroids lowered significantly, organic chemists could begin thinking about how to overcome the problem of metabolism. In 1951, a team of chemists named Durossi, Miramontes, and Rosenkrantz succeeded in synthesizing a synthetic analog to estradiol called norethindrone, which was able to be ingested. The key ingredient, synthesized from a molecule found in yams, enabled the large-scale production of birth control pills for the first time in human history. Synthesis of norethindrone proceeds through 6 synthetic steps beginning with estradiol. Students of second semester organic chemistry should recognize all the reactions needed to create the final product. The first step is to make the 3-methyl ether of estradiol through Williamson ether synthesis. In step 2, a Birch reduction converts the aromatic ring into a diene. Step 3 is the so-called Oppenauer oxidation of a secondary alcohol into a ketone. In the 65 years since the synthesis was carried out, newer reagents have been discovered. The fourth step is the addition of a tertiary alcohol to the carbonyl carbon using lithium acetylide. A weak acid is used to quench the resulting alkoxide. In step 5, acid is used to hydrolyze the ether, and finally in the last step, the double bond shifts over one position so that it's conjugated with the ketone. This simple synthetic procedure for producing norethindrone provided the key ingredient to the pill chemists had been hoping for. It's estimated that over a third of women in the USA have taken some type of birth control pill during their reproductive lifetime, and over 100 million women worldwide are taking it now. The technological advantage laid the groundwork for the social change of the 1960s. So next time you have sex, thank the yams.